The American Healthcare Association, or AHCA, does not specify a required length of time for a load study on an existing hospital life safety panel. However, the AHCA offers guidance on the general process which helps estimate the time needed. Let's review that general process. Firstly, identify the electrical system for study. This includes all electrical equipment and circuits connected to the life safety panel. Secondly, record the current load on the electrical system. This involves load monitoring equipment. Thirdly, simulate the maximum potential load on the electrical system. This simulation is achieved by connecting additional electrical equipment or simulating a power outage. Fourthly, record the voltage and current levels on the electrical system. Fifthly, analyze the data to determine if the electrical system can handle the maximum potential load. This analysis compares the recorded voltage and current levels to the manufacturer's specifications for the electrical equipment. The time required for a load study varies based on the size and complexity of the electrical system. A general estimate for completion is 2 to 4 days. Several factors can affect the time required. Firstly, the size of the electrical system is a factor. Larger electrical systems require more study time. Secondly, the complexity of the electrical system is another factor. Electrical systems with multiple circuits and equipment need more time to study. Thirdly, the availability of equipment affects the time required. The availability of load monitoring equipment influences completion time. Fourthly, the experience of the personnel conducting the study is a factor. Experienced personnel typically complete the study faster. Consider a scenario where a hospital is expanding its facilities and adding new medical equipment to a life safety panel. A load study becomes necessary to ensure the existing electrical system can handle the increased load. Following the AHCA's general process, the electrical engineer would firstly identify all the components connected to the life safety panel, including lighting, emergency power outlets, and critical medical devices. Secondly, they would use load monitoring equipment to record the current load under normal operating conditions. Thirdly, they would simulate the maximum potential load by either connecting additional equipment or using software to model a power outage and the activation of all life safety systems. Fourthly, voltage and current levels would be carefully recorded at various points in the system. Fifthly, the collected data would be analyzed to determine if the electrical system can handle the maximum potential load without exceeding its capacity or experiencing voltage drops. If the analysis reveals that the electrical system is inadequate, the engineer would recommend upgrades or modifications to ensure the safety and reliability of the life safety systems. For example, let's delve further into simulating the maximum potential load. This step is crucial because it tests the electrical system's response under the most demanding conditions. The simulation might involve activating all emergency lighting, running all critical medical equipment at the maximum power draw, and starting up backup generators simultaneously. During this simulation, the voltage and current levels are monitored closely to identify any signs of overload or instability. If the voltage drops too low, it could indicate that the system is unable to provide sufficient power to all the connected devices, potentially causing them to malfunction. Similarly, if the current exceeds the rated capacity of the wiring or circuit breakers, it could lead to overheating and potentially a fire. The analysis phase involves comparing the recorded data against established standards and manufacturer specifications. For example, the National Electrical Code, or NEC, provides guidelines for the allowable voltage drop in electrical circuits. If the voltage drop exceeds these limits, it could indicate that the wiring is undersized or that the system is overloaded. Similarly, the manufacturer's specifications for the electrical equipment will specify the maximum allowable current draw. If the current exceeds these limits, it could damage the equipment or shorten its lifespan. Consider the impact of harmonics on the electrical system. Harmonics are distortions in the voltage and current waveforms that can be caused by nonlinear loads such as electronic devices and variable frequency drives. These harmonics can cause a variety of problems, including overheating of transformers and conductors, malfunction of sensitive electronic equipment, and increased energy losses. During a load study, it's important to measure the harmonic content of the electrical system to identify any potential problems. If harmonics are present, mitigation techniques such as installing harmonic filters may be necessary. Another important aspect of a load study is to verify the proper operation of the emergency power system. This includes testing the automatic transfer switches, or AHCAs, which are responsible for switching the electrical load from the normal power source to the backup generator in the event of a power outage. The ATS should be tested regularly to ensure that they can quickly and reliably transfer the load to the generator. Additionally, the backup generator should be tested under load to verify that it can provide sufficient power to all the essential equipment. Let's explore the specific equipment used in a load study. Firstly, load monitoring equipment is essential. This equipment typically includes current clamps, voltage probes, and a data logger. The current clamps are used to measure the current flowing through the conductors, while the voltage probes are used to measure the voltage at various points in the system. The data logger records the measurements over time, allowing for analysis of the load profile. Secondly, power quality analyzers are important. These devices measure voltage, current, harmonics, and other power quality parameters. They can help identify potential problems with the electrical system, such as voltage sags, voltage swells, and harmonic distortion. Thirdly, thermal imaging cameras are useful. These cameras can detect hotspots in electrical equipment, such as transformers, circuit breakers, and conductors. Hotspots can indicate potential problems, such as loose connections, overloaded circuits, or insulation breakdown. Fourthly, ground resistance testers are needed. These devices measure the resistance of the grounding system. A low resistance ground is essential for safety, as it provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Fifthly, insulation resistance testers, also known as megometers, are useful. These devices measure the resistance of the insulation on electrical conductors. A high insulation resistance is essential for preventing electrical leakage and short circuits. Let's discuss some of the challenges that can arise during a load study. Firstly, access to equipment can be a challenge. In some cases, it may be difficult to access the electrical equipment that needs to be monitored. This can be due to physical obstructions, safety concerns, or operational constraints. Secondly, coordination with hospital staff can be challenging. It's important to coordinate with hospital staff to minimize disruption to patient care. This may require scheduling the load study during off-peak IOs or working in close collaboration with the facilities management team. Thirdly, unexpected problems can arise. During the load study, unexpected problems may be discovered, such as faulty equipment, wiring errors, or overloaded circuits. These problems need to be addressed promptly to ensure the safety and reliability of the electrical system. Fourthly, data analysis can be time-consuming. Analyzing the data collected during the load study can be time-consuming, especially for complex electrical systems. It's important to have experienced personnel who can interpret the data and identify any potential problems. Let's consider the importance of documentation. Proper documentation is essential for a load study. This includes documenting the scope of the study, the methodology used, the data collected, and the results of the analysis. The documentation should also include any recommendations for improvements or repairs to the electrical system. The documentation should be kept in a safe and accessible location for future reference. For example, consider a scenario where a hospital is undergoing a major renovation project. As part of the renovation, new electrical equipment is being installed, and the existing electrical system is being modified. A load study is required to ensure that the electrical system can handle the new load and that the modifications are safe and compliant with applicable codes and standards. In this scenario, the load study would involve, firstly, identifying all the electrical equipment that is being added or modified as part of the renovation project. Secondly, collecting data on the existing electrical system, including voltage, current harmonics, and power factor. Thirdly, simulating the maximum potential load in the electrical system, taking into account the new equipment and the modifications to the existing system. Fourthly, analyzing the data to determine if the electrical system can handle the new load and that the modifications are safe and compliant. Fifthly, documenting the results of the load study and making recommendations for any necessary improvements or repairs to the electrical system. Let's consider another scenario where a hospital is experiencing frequent power outages. A load study can be used to identify the cause of the power outages and to recommend solutions to prevent them from occurring in the future. In this scenario, the load study would involve firstly collecting data on the electrical system, including voltage, current, harmonics, and power factor. Secondly, analyzing the data to identify any potential problems such as overloaded circuits, faulty equipment, or voltage sags. Thirdly, simulating the power outages to determine the cause of the outages. Fourthly, documenting the results of the load study and making recommendations for any necessary improvements or repairs to the electrical system. Let's discuss the importance of following industry best practices. When conducting a load study, it's important to follow industry best practices to ensure the accuracy and reliability of the results. This includes using calibrated equipment, following proper measurement techniques, and documenting all data and findings. It's also important to be aware of the limitations of the load study and to interpret the results accordingly. For example, a load study is typically a snapshot in time, and the results may not be representative of the electrical system's performance under all operating conditions. Therefore, it's important to consider the potential for future changes in the electrical load and to plan accordingly. Let's talk about the role of qualified personnel. Load studies should be conducted by qualified personnel who have the necessary training and experience. This includes electrical engineers, electricians, and other professionals who are knowledgeable about electrical systems and load study techniques. Qualified personnel can ensure that the load study is conducted safely, accurately, and in accordance with applicable codes and standards. They can also provide valuable insights and recommendations for improving the performance and reliability of the electrical system. Furthermore, consider the ongoing monitoring of the electrical system. A load study is not a one-time event. The electrical system should be monitored on an ongoing basis to ensure that it continues to operate within its design parameters. This can be accomplished through regular inspections, periodic load studies, and the use of monitoring equipment that provides real-time data on the electrical system's performance. Ongoing monitoring can help identify potential problems early on, before they lead to equipment failures or power outages. The American Healthcare Association's guidance emphasizes a systematic approach to assessing the electrical infrastructure of healthcare facilities. Understanding the factors that influence the time required for a load study, such as the size and complexity of the system, equipment availability, and personnel experience, is crucial for effective planning and execution. Furthermore, the use of appropriate equipment and adherence to industry best practices are essential for accurate and reliable results. Finally, engaging qualified personnel and implementing ongoing monitoring programs are key to maintaining the safety and reliability of the electrical system in healthcare facilities. When simulating the maximum potential load, one must consider various scenarios that could place the highest demand on the electrical system. In a hospital setting, this might include a combination of factors such as peak patient occupancy, simultaneous operation of all medical imaging equipment, and the activation of all life support systems. The simulation should also account for the potential impact of external factors such as extreme weather conditions, which could lead to increased demand for heating or cooling. By carefully considering all of these factors, the load study can provide a comprehensive assessment of the electrical system's ability to handle the maximum potential load. When analyzing the data collected during our load study, it's important to consider not only the magnitude of the load but also its characteristics. For example, some types of equipment, such as variable frequency drives, can draw current in a nonlinear fashion, which can lead to harmonic distortion. Harmonics can cause a variety of problems, including overheating of transformers and conductors, and can also interfere with the operation of sensitive electronic equipment. Therefore, it's important to measure the harmonic content of the electrical system during the load study and to take steps to mitigate any problems that are identified. When documenting the results of a load study, it's important to provide clear and concise information that can be easily understood by stakeholders. This includes providing a summary of the findings, a description of the methodology used, and any recommendations for improvements or repairs to the electrical system. The documentation should also include detailed data on the electrical system's performance, such as voltage, current, harmonics, and power factor. By providing comprehensive and well-organized documentation, you can ensure that the load study is a valuable resource for years to come. Consider the impact of preventative maintenance on electrical systems. Preventative maintenance is a proactive approach to maintaining electrical systems that involves regularly inspecting, testing, and servicing equipment to prevent failures and extend its lifespan. Preventative maintenance can help to improve the reliability of the electrical system, reduce the risk of power outages, and lower overall maintenance costs. Some common preventative maintenance tasks include tightening connections, cleaning equipment, lubricating moving parts, and testing insulation resistance. By implementing a comprehensive preventative maintenance program, you can ensure that the electrical system is operating at peak performance and that it is less likely to experience unexpected problems. When conducting a load study, it is useful to understand how the information collected can be used to optimize the electrical system's efficiency. Energy efficiency is an important consideration for any organization, and it can be particularly critical in healthcare facilities, where energy costs can be a significant expense. By analyzing the data collected during a load study, you can identify opportunities to improve the electrical system's efficiency, such as reducing energy waste, optimizing equipment operation, and implementing energy-saving technologies. Some common energy efficiency measures include using high-efficiency lighting, installing variable frequency drives on motors, and optimizing the building's HVAC system. By implementing these measures, you can lower energy costs, reduce your carbon footprint, and improve the overall sustainability of your organization. In addition to the technical aspects of conducting a load study, it is also important to consider the regulatory requirements that may apply. Healthcare facilities are subject to a variety of regulations related to electrical safety and reliability, and it is important to ensure that the load study is conducted in compliance with these regulations. Some common regulatory requirements include the National Electrical Code, the Joint Commission standards, and state and local building codes. By understanding and complying with these regulations, you can ensure that the electrical system is safe, reliable, and in compliance with applicable laws. Let's delve into the benefits of using software tools for load studies. Software tools can greatly simplify the process of conducting a load study and can provide a wealth of information that would be difficult or impossible to obtain manually. These tools can automate many of the tasks involved in a load study, such as data collection, analysis, and reporting. They can also provide advanced features such as real-time monitoring, predictive modeling, and what-if analysis. By using software tools, you can improve the accuracy and efficiency of the load study and gain a deeper understanding of the electrical system's performance. Some popular software tools for load studies include AHCA and Power Tools, and Easy Power. In conclusion, load studies are crucial for maintaining the safety, reliability, and efficiency of electrical systems in healthcare facilities. By understanding the process, considering the influencing factors, using the appropriate equipment, and following industry best practices, you can ensure that the load study is a valuable tool for managing your electrical infrastructure. Engaging qualified personnel, implementing ongoing monitoring programs, and complying with regulatory requirements are also essential for success.